This is PyData Global. Welcome back to PyData Global. This is the LLM track, and in this talk, we have a great talk called Holistic Evaluation of Large Language Models from References to Human Judgment. So I'm going to hand over to Ria Joshi and Paran Jhaveri. I hope I pronounced that right. So this talk is in the evolving field of natural language processing. I'm just reading here from the side, folks. The evaluation of large language models is crucial for understanding their performance and guiding their development. This talk delves into two primary evaluation methodologies: reference based and referenceless techniques. Okay, so I realize I'm just going to have to do some of that again because I forgot to press record. And do we have a recording button? Just bear with me.
Oh, it shows currently recording session.
Oh, thank golly. Okay, well that's good. Sorry, I just wanted. This is my first time doing this, folks. Apologize for that. Right. Well, sorry. I'll let you take it away there. That was a little bit of a faux pas on my part. I'll let you work away, folks.
Totally.
I'll go backstage and let you work away. Thank you very much.
Thanks a lot, Kevin. And hi everyone. Welcome to the holistic evaluation of large language models. This is your host, me, Ria Joshi, and Parin Jhaveri. So the agenda of our talk is we are going to talk about why evaluate LLMs. What is LLM evaluation? We're also going to talk about some of the methods to evaluate LLMs, statistical methods, embedding based metrics, and LLM as a judge. Then we'll walk you through some example of how to design a evaluation technique for summarization using LLM as a judge. So, why even talk about evaluating LLMs? So, large language models have surged in popularity due to their exceptional performance in diverse applications, both in research and in daily use. However, industries that handle sensitive and highly confidential data, such as medical and financial sectors, must be very vigilant and about the potential risk of integrating LLMs into their system. There are some key risks of LLM integration. For example, one is to ensure quality. That is, LLM responses must be evaluated for ambiguity and factual accuracy. We would also want to ensure that LLM responses do not contain societal biases, offensive language, or harmful content. Some examples of potential issues with LLM responses are shown on the right here in the slide. We have factually inconsistent response from LLM about the first person to land on the moon. And in the second example, when prompted on how to create a deadly poison, the LLM actually proposes a method. These examples highlight the importance of evaluating LLMs to ensure they align with our preferences and standards. Sorry. LLM evaluation refers to the process of ensuring LLM outputs are aligned with human expectations, which can range from ethical and safety considerations to more practical criteria such as the correctness and relevance of the outputs. Evaluating LLMs are multidimensional. It all boils down to what you really care about, what type of task you're solving. Here are a list of few of those metrics. This is not an exhaustive list, but just a subset to give you a sense. For example, accuracy that measures how well aligned is model's response with factual knowledge. Then comes relevance, how well the model's response addresses the user question or user input. Then comes fluency. Now, these models are trained to mimic the human language, so they need to do it correctly. Fluency measures that. Then comes coherent. Their answers or the output that these models generate, they need to be logically consistent. Then comes safety and fairness, which I feel is one of the most important ones. It means that your model is free from societal bias or harmful content or offensive language. These models have been trained on huge corpus of data, and sometimes they pick up from those biases that are present in that data. And we want to ensure that our models are free from that. Then comes task specific metrics. Now, the different tasks require different components, different architectures, and then hence different components might need different evaluation strategies. For example, summarization might need something different compared to question answering. The diagram on the right depicts the evaluation architecture, where the dashed lines are optional inputs and the solid lines are required inputs to the evaluator. The evaluator method then gives a score and optionally a reason of why this score was given. This score helps us understand how well the LLM is performing on the given evaluation method. We can broadly categorize the evaluation methods for large language models into two main types: reference based and reference less evaluation. Reference based evaluation involve having input and output data points from either human annotated datasets commonly used in academia or synthetic dataset. This method allows for direct comparison of LLM output with the expected test output. Example of metrics used in this approach include statistical metrics like blue score or Rouge, embedding based metrics like bird score, cosine similarity, and even leveraging powerful LLMs as evaluators. On the other hand, reference less evaluations are typically employed when there are insufficient or no input output data points available for testing, reflecting practical scenarios often seen in the industry. In this method, we generally prompt the evaluator LLM to assess the LLM output based on specific criteria. Sometimes the input to the predictor LLM is also incorporated in the evaluation process. As an example of this would be evaluating the relevance of the LLM output in relation to the provided input.
So let's talk about statistical metrics. Statistical metrics measures the overlap of tokens or words between generated outputs and the reference text. Examples are the blue metric, Rouge N, and the meteor metric. The advantage are that it is not computationally intensive, and these metrics have been widely used since even before the advent of LLMs. Hence, it is one way of benchmarking LLM outputs. The major disadvantage of these methods are that it doesn't cater for different words that have the same meaning. That means it measures only the syntactical matches rather than actual semantics, which is the actual meaning of that particular body of text. Let's take a look at an example. If you look at the example reference and prediction, these sentences actually say the exact same thing, but in different wordings. We have the reference sentence stating the person took their dog for a walk in the lawn, and the LLM prediction given the human took their pet hound for a stroll in the backyard. As you can see, these sentences mean exactly the same thing. But we only get a root score of 60.8 percentage. That is because the word overlap is quite low. If we look at the second example, these two sentences are completely different. The first is about taking your dog out for a walk on the lawn, and the second is that they wore their headphones for a walk on the lawn. But because the word overlap is high, we get a pretty high Rouge F1 score of 83.31 percentage. So from here, we can say that LLM outputs may have the same statement meaning, but they use different words. And hence, we need a metric that looks into text similarity and not just relies on looking at the word overlaps. This brings us to embedding based metrics. Metrics in this bucket generally vectorizes the reference text and the output from the model separately. These vectors are called text embeddings, and they are the mathematical representations of that body of text. We then compute the similarity of these vectors, that is, the reference vector and the generated output vector. Example of embedding based metrics are BERT score, Blewett score, and cosine similarity. These metrics enable us to be able to measure the semantic similarity between two bodies of text. But it fails in capturing task specific nuances, such as how factually correct or relevant the generated output is as compared to the input. Let's take an example of one of these metrics, BERT score. The reference text or the expected output is the weather is cold today. And let's say the generated output by the LLM is it is freezing today. These two sentences are quite similar. While they might not mean the exact same thing, they they are actually quite similar. If we use statistical metrics, that is just the overlap of words, we would get an abysmally low score. But as shown here, the bird score metric is able to compare the similarity of embeddings at a token level and gives a reasonably high similarity value of 75.3%. We generally expect LLMs to output text in their own words, so it makes sense to use this metric to compare it with the expected test output. But the previous two methods, statistical and embedding based metrics, have been, while they are foundational in LLM evaluation, they have come with significant practical challenges. Let's unpack these disadvantages, focusing on the constraints they impose on modern workflows. Both statistical and embedding based metrics depend on pre existing datasets with clear input output mappings or gold standard answers. This dependency limits their flexibility, especially in tasks with open ended or creative outputs. Examples are generating novel ideas, summaries, or conversational responses. These don't always align well with predefined references. Creating a test data set has additional challenges too. Number one, it is expensive. Creating high quality reference data sets often requires domain experts or skilled annotators, making it costly. This becomes a barrier for smaller teams or organizations with limited resources. The second disadvantage is it is time consuming. The process of curating, annotating, and validating data is slow, introducing delays in workflows. This is now especially problematic in dynamic industries using AI, where rapid iteration is crucial. Finally, statistical and other reference based evaluation workflows are not well suited for iterative and agile development that LLMs enable. Teams looking to quickly test ideas or build proof of concepts face delays due to the dependency on annotated references and rigid metrics. This limits the potential to innovate or adapt rapidly in evolving use cases.
So let's discuss LLM based evaluations, also known as LLM as a judge. In this approach, we use another LLM, typically a more powerful one than the predictor LLM, to evaluate the outputs. Sorry. This method can be applied in scenarios with or without labeled data. As Pardon already covered, that in industry it's very difficult to get labeled data, so it's very important that we find options of how we can work with non-labeled data. There are obviously huge pros of using LLM as a judge. They capture the semantic similarity of complicated LLM outputs more effectively than any other methods. They can be used even in the absence of label data, which is important in references evaluations. They are suitable for task specific evaluations as well. You can also create custom evaluation criterias and metrics using LLM as evaluators. But there are obviously some cons that are worth considering. LLMs are expensive to use. Every input output token, you need to pay for it. Using LLMs to evaluate other LLMs can introduce potential biases, making it necessary to assess the quality of the custom evaluation itself. Some of the very popular frameworks that are used for evaluation as a judge are GEval and DeepEval. We're going to talk about one of them, which is called GEval. GEval framework enables referenceless evaluation of LLM outputs. So it works in the following steps. First, the user describes the evaluation task and the desired evaluation criteria. Then an LLM is prompted with this evaluation description to auto generate evaluation steps using chain of thought prompting. These evaluation steps can be perceived as detailed action plan on how to achieve the evaluation goal. Then the evaluated LLM uses these evaluation steps along with the input and output from the predictor LLM to score the predictor LLM's output.
Let's look at an example, especially in particular for summarization. This is an example of the entire prompt constructed using the G-eval framework to evaluate coherence in the summary. As part of the first step, the data scientist would provide an evaluation description along with the criteria. For example, the criteria written here for coherence is coherence 1 to 5, which is the range of scores, the collective quality of all sentences. We align this dimension with the DUC quality question of structure and coherence, whereby the summary should be well structured and well organized. The summary should not just be a heap of related information, but should build from sentence to sentence to a coherent body of information about a topic. So this particular part, which the evaluation criteria, as Ria mentioned, is written by the data scientist itself. This evaluation criteria and the previous evaluation description is given to the evaluator LLM to generate these evaluation steps, which is basically a chain of thought to help the evaluator LLM to evaluate how good the summary is on the coherence metric. So, if we look at the evaluation steps generated out here, we can see that the LLM generated read the news article carefully and identify the main topic and key points. Read the summary and compare it to the news article. So, as you see below here, the source text is actually the news article, and this is the summary just below it. The source text was actually given to the predictor LLM before, and the summary being generated was from the LLM output. So both of these, the input and output to the predictor LLM, is provided also as part of the prompt to GEval. So check if the summary covers the main topic and key points of the news article, and if it presents them in a clear and logical order. Assign a score for coherence on a scale of 1 to 5, where 1 is the lowest and 5 is the highest, based on the evaluation criteria. Finally, the evaluation description, these evaluation steps, the input to the predictor LLM, which is the news article itself, the predictor LLM output, and the prompt to give the scoring output is given as input as an input prompt to the evaluator LLM. Here is another example for detecting hallucinations in summaries. So this is the entire prompt constructed using GEval framework to detect hallucinations in the summary without auto-generating the evaluation steps. Generally, as part of the GEval paper, as we have cited later in the slides, it is recommended to basically generate these evaluation steps as it gives the evaluator LLM a chain of thought of go about how to go about this particular metric. But as hallucination detection is a pretty common way of checking how good the summary is, it seems that the data scientists out here decided not to generate evaluation steps. In fact, they only provide an evaluation description by calling it factual consistency. They basically ask the evaluator LLM to see if the summary is untruthful or if any misleading facts exist within the summary. Similarly to similarly to the coherence prompt, we still give the source text, which is the news article, and the summary generated by the predictor LLM. With all of these inputs and the binary scoring function, which is basically a yes or no, that does the summary contain factual inconsistency. With all of these elements as part of the prompt, it is provided as input to the evaluator LLM. And this is done for each summary, and then you can basically decide how good the predictor LLM is at generating factually consistent summaries. So how do these different evaluation methods compare to one another and to human evaluations? Well, let's understand this table provided in the GEval paper for evaluating summaries. In the first column, you have the list of statistical embedding-based and LLM-based metrics that we discussed. The other column headers are different evaluation dimensions used for evaluating summaries. You have coherence, consistency, fluency, and relevance. The final column is basically an average of all of these numbers. Now, what are these numbers? The numbers under each of these particular dimensions are the Spearman and Kendall Tau correlations, which indicate how well each evaluation metric aligns with the human judgment for each of these dimensions. Higher the values, the more they are correlated. So metrics like Rouge and birth score perform poorly across these dimensions. As you can see, they are around for coherence, they're around the zero point 0.2 mark. For consistency, they're around the zero point 0.1 mark. So this is indicated by the low Spearman and Kendall correlations. Average scores reinforce their limitations in evaluating nuanced LLM outputs. Metrics like Jhaveri score and G-eval4, which use LLMs for evaluations, show higher correlation with human judgments. For example, G-eval4 achieves the highest average, closely matching human evaluation standards. To summarize, reference-based evaluation methods face a ton of challenges. These methods rely heavily on label data, which is often unavailable or expensive to generate. Their rigidity limits their applicability to real-world diverse tasks. LLMs as judges prove to be a promising alternative. LLM-based evaluations align more closely with human assessments, making them a strong candidate for replacing reference-based metrics. GEVAL 4, for example, consistently outperforms traditional metrics. Despite their advantages, LLMs as judges are not without flaws. They suffer from biases and variability, as even Ria mentioned, making them less reliable than direct human evaluation.
Here are our final conclusions and recommendations. Human evaluation is still by far the best method to evaluate LLM outputs for any task. Statistical methods are foundational but limited to syntactic comparisons. Embedding based methods can ease the constraint by looking into semantics as well, but doesn't provide insights on how well the model is doing on a task. LLM based methods show promise but still falls short of human level evaluations. Here are some of the recommendations that you might use when you're developing your evaluation strategies for LLMs. Combine multiple evaluation methods for robustness. Choose the most meaningful and representative subset of data to be evaluated by humans to get an accurate approximation of model performance. These are some list of references that we used while researching for this presentation. You can, if you want to learn more, you can go ahead in all of these references. They are really helpful. This is mine and Parents LinkedIn. Thank you for attending this session and feel free to connect with us.
Great stuff. Thank you very much for that. I really appreciate your talk. Uh, just for the folks at home, if you have any questions, there is a Q&A menu on the vertical menu. There's a Q&A functionality on the vertical menu bar on the right hand side, just beside the chat. So if you have any questions that we can ask there, because we've got a few minutes. Um, just actually, I'll ask one just first off, just because just for the sake of time, I didn't really give you any proper sort of biographical information in my introduction. But if you want to give yourself a little bit of a biographical information about yourself, about your career, and any advice, you know,
Mhm.
for people up and coming in your career.
Yeah, sure. I can start. So I've been working as data scientist in Microsoft for about 2 years. Before this, I completed my master's from UMass Amherst, which is in computer science and AI from United States of America. And currently, I'm also working out of West Coast, Redmond, Seattle. Um, the only advice for anybody coming into this is a very evolving field, and sometimes it can be really daunting, but the thing is it's very interesting, and there are because of the more and more LLMs coming into the field, it has become very interesting and easy for even any new person to get on board, because it's a new chapter in the whole field of data science and AI, so it's a good place to start if anybody is looking into it.
Yep.
Yeah, I'll let you take that question there. The question has just popped up in the chat, but I'll let you work away first. So, Paran.
Yeah, so yeah, my name is Paran Jhaveri. I've been working for the past 2 years with JP Morgan as an applied scientist. Prior to that, similarly to Ria, I also did my master's from University of Massachusetts Amherst, and I graduated in December 2022. Before that, I acquired around 3.5 years of work experience at Cisco back in India. So yeah, that's a bit about myself. And the advice that I'd give for upcoming people, one is for students, if you're in your undergrad or you're in your postgrad, I would suggest definitely try to dabble into some research, maybe get in touch with a few professors or PhD students, and then do some research with them that will get you well introduced to the field. For industry practitioners, the great thing about LLM before getting into this applied science domain was a big challenge, as it was heavy on math and very heavy on concepts and very particular type of Python programming. Now with the advent of LLMs, with the advent of LLMs, it has democratized and it has become more available for people to learn and ramp up. So yeah, I would suggest there are courses now and then popping up. There are certain books also that have come. I would suggest pick a few of them that you like, and that would basically give you a good background in coming into this field. Yeah.
Good stuff. So, just from the chat, I'll just call it out in case people who are watching this on the recording can't see it. For the G eval scoring assessment, is it usually done over a randomized or a stratified sample, or are you doing it over an entire set of outputs?
So I can take this question. So you generally do it on the entire set of outputs. Now, of course, it also depends on on basically on the cost. If let's say let's say costs are not an issue, then yes, you would want to do it on the entire set of outputs so that you get a good understanding as to how well your particular task is doing, as GEVAL helps in task specific metrics.
Mhm.
If let's say costs are an issue, then it would be important to choose your samples. I would Randomized is usually not the best way. I think that would be that would maybe a baseline. But the way to sample would be to choose the most representative examples. If let's say you're looking at a multi-class classification problem rather than randomizing it, you may want to choose some particular examples which from each class in a balanced way. And you may also want to choose those samples which you know are like hard negatives, which are basically borderline between two classes. So that would give you a good that would give you a good representation of your data set and to see how well it is doing on easy and hard examples.
Good stuff. For the second question, hi. For the LLM as a judge method, how well did you measure the underrepresented languages for inaccuracy?
So, okay. How well did you measure the underrepresented language? Are you saying low resource? How
I'm
well
going to
does
make a guess here, just like let's say languages with only a couple of like about 10 million people. So I'm just going to make a guess here and say Hungarian and Danish and languages like that are not
right?
prevalent like English or Hindi that have less native speakers.
Right. So when you're looking for underrepresented languages, or like low resource languages as we call it, in that case, what is good about LLM as a judge method is that you get to choose the LLM that you want to use for the evaluation. So if you're looking at a low resource language, you basically would want to use that particular LLM to evaluate. So generally, as we had mentioned, we you have your predictor LLM, which actually does predicts the task, and then you have your evaluator LLM. If you have if it if it fits within your cost budget and everything, you might use the most powerful LLM for both the evaluation and the predictor. But generally speaking, what people do is for the predictor LLM, they use a more maybe domain adapted LLM or a smaller one. And for the evaluator, they use a very powerful one.
Yeah.
So in yeah,
Just
Dia,
to
you want
add
to?
on it, for example, a GPT or based LLM is powerful, have been trained on many languages, so it might be used as an evaluator that can have more context and help us evaluating more. And for a predictor LLM, it can be a small LLM, which is maybe some open source LLM, which is fine tuned for your use case. So yeah, for underrepresented languages, the best way is you would want to use an LLM that has been pre-trained on as many languages as possible.
Excellent. Thank you very much for that, folks. I think we'll have to leave it there. Our time is up. But just to sort of remark and echo something that you said previously, I believe that you invited the audience members to reach out to you on LinkedIn.
Mhm.
And
Yep,
those are your profiles there. And that, if you want to follow up, if the audience members want to follow up, you're very open for questions there.
sure.
Great stuff. So
Thank you.
We are
sorry,
on the Discord too. We are on the Discord channel too, so
oh
you can
yeah, and the
even
Discord channel as well.
yeah,
So just actually one remark related to that last question. Thanks, for example, in Hungarian, the GPT-4 only performs about 80% of the human baseline, so fine tune is the solution. That's just a little follow up on that previous question.
right.
Thank you very much, folks. That was a great talk and a really great questions there, and great to see a lot of vibrancy in this setup. But unfortunately, we have to call time on this session and allow our speakers to step back and relax, and also get ready for the next session. So there is the Discord channel and the reception area as well. So we encourage all the attendees to mingle in between sessions. So that's it. Thank you very much, folks, and I
Thank
wish you a
you.
good evening or
Thank
a
you,
good
Thank
everyone.
day.
you. Thanks,
Bye
everyone. Thank you.
bye.